Okay, way back at the beginning of class, we looked at some laws of exponents, rules for exponents that are always true. What we'd like to do now is look at kind of the same deal for logarithms. What are some rules for logarithms that are always going to be true? Okay, so I'm going to start off with this one. No matter what base you're looking at, the log base b of 1 is always going to be the same number. We might have mentioned this in passing a couple of times already. Just keep in mind, if I need to find a logarithm, I'm always looking at what's the missing exponent. The base is b, the answer is 1. What's the exponent that's going to make this happen? We've done this already. We've done problems like this already. Anything to the 0 power would be 1. It's a missing number. The question mark is a 0. Okay, similar. If I take a log base b of b, no matter what number b is, I guess assuming b is positive, because otherwise it doesn't even make sense for a variety of reasons, then this is saying the base is b, the answer is b. What's the missing exponent? Well, anything to the first power is equal to itself, so apparently the question mark or the missing number is 1. I guess I should go back and fill in the blanks. This was a 0, and this is a 1. So this is the corresponding rule of exponent for the rule of logarithms or law of logarithms on the left-hand side. Okay, next up is a little more interesting one. Now, we might be able to think our way through this same way as we did the previous ones. You know what, let's go ahead and try it. So the base is b, the answer is b to the x. And so we're thinking to ourselves, b to what power makes b to the x? And you should be able to spot if these two things are going to be equal, then the question mark had better be the same as x. That actually looks like something we've seen before, though. We have a function with something on the inside, and the answer ends up being an x. Also, there's a relationship between b to the x and log base b. If I think about this in a different way, if f of x is equal to b to the x, and f inverse, the inverse of an exponential would be a logarithm, then what I have written down here, we have a logarithm on the outside, we have a b to the x on the inside, logarithm meaning f inverse on the outside, exponential meaning f of x on the inside, and this was one of our rules. One of the ways that we defined a function's inverse is that it should be that a function composition, its inverse, should take you back to wherever you started. Okay, so hopefully that makes some sense that this is actually just an exponential and logarithm version of the equation we've seen before, which is a function and its inverse. When you take a composition, you should get back to the original x. Okay, well, since I just finished thinking about it this way, we should also be able to do in the reverse order. Should be able to put the inverse function on the inside. If I do that, then the logarithm is on the inside. So this is f of log base b of x. But the function f is b to an exponent. So f of big mess is equal to b to a big mess. And so there's actually two ways that we can see this rule. One is if we take a log of an exponential and they have the same base, then the log and the exponential essentially kind of cancel. Right? The b and the log base b cancel out, and you just get x left over. And like a square root and a square cancel each other out, or a cube root and a cube cancel each other out. Same thing here, if we have a base b and a log base b, those two should cancel out. This is really small and on the edge of the board. Let's try rewriting this. I don't need the rest of this chunk, so let's erase and give this formula the glory it deserves, or at least write it large enough to be legible. Okay, so something to be aware of here. This is a base b, and this whole thing in parentheses is the exponent. So b to a power log base b of x. So that's applying an exponential function to a logarithmic function. The two should essentially cancel out, and we get x. So just a real quick example of that. If I ask you to find log base 7 of 7 to the x, we should be able to say this is just going to be x. If I asked you to find 576 to the power log base 576 of 16, good luck typing that in a calculator. I'm not going to bother because I have an exponential function and a logarithmic function with the same base. They're inverses of each other. They should cancel out. Our answer should be 16. Same deal as a square root and a square or a cube root and a cube. They cancel each other out, and we just have whatever's on the inside is left over.